Even in class, we are looking at college algebra practice test number 1, module 1, covering chapter 2, equations and inequalities. We're going to go over the second half. We covered the first half. First, we started with distance and midpoint formulas. We looked at an application problem involving Pythagorean theorem, a squared plus b squared equals c squared. We solved a rational equation. There are two things we need to remember. We need to factor every denominator. We're going to multiply both sides by LCD, and we're going to exclude whatever makes each and every one of the denominators 0. So when we get the final answer, you check with that part. Different equations of lines were discussed: slope, horizontal lines, vertical lines, parallel lines, perpendicular lines. And the slope is known as the average rate of change of y with respect to x. We looked at equations involving vertical lines and horizontal lines. Given a couple of pairs, x comma y, we were interested in finding the equation of a line. In general, in order to find the equation of a line, we need two things. We need a pair and the slope. So when they say a line is perpendicular to this line or parallel, that gives us a situation where we can go through the process of finding the slope. This was an investment problem, which is a kind of mixture problem. The reason it's called a mixture problem because these two parts, the volume or the amount in this case, they add up to this constant. That's what's called a mixture problem. In this example, we looked at a motion problem. D, the distance, is the product of RT, rate, and time. Rate is the average speed. This was another example of applications, basic geometry, where we know the perimeter of a rectangular shape is 2 times the width plus 2 times the length, and we solve this problem. All right, we're going to move on to the next part. We want to perform the indicated operation. As you can see, we want to add -1 plus 2i and -2 plus 3i. Well, we are dealing with complex numbers that are defined as a plus bi. With that, I by definition is square root of -1, and therefore square root of -n is I times square root of n. When we multiply these two, we get a squared minus b squared I squared, and I squared is -1. So -1 times -1 makes it positive. Therefore, it results in a squared plus b squared. Now, when we go back to the question given, we have to multiply simply by foiling. So we're going to multiply -1 by -2. That gives us +2. We're going to multiply -1 by 3i, it gives us negative 3i. We're going to multiply these two. We get negative 4i. And if we multiply these two, we get plus 6i squared. Since I squared equals negative 1, so I by definition is square root of negative 1. If you square it, it becomes negative 1. I cubed is the product of I squared and I. So I squared times I minus I. And I to the power of 4, again, is multiply these two, or just say I squared to the second power. So let me just make sure everybody understands how we arrive. The answer, this is I squared, which is negative 1 to the second power. Therefore, let's clean it up and write it with a different color. Makes it easier to understand. So this is I squared to the second power. So if you put negative 1 here to the second power, becomes positive 1. So over here, everything is fine. We're going to change this to minus 6. We're going to combine 2 and minus 6. We get negative 4. We're going to combine these two into negative 7i, and we are done. Complex numbers. To do this, we are, if they say divide, rationalize, or put it in standard form. This is the standard form. It all means the same thing. You multiply by the conjugate of the denominator. So remember, the conjugate for a plus b is a minus b. For a plus bi is a minus bi. And the reason you do that, because their product is a squared plus b squared. Either perform the foiling or just do the product as I did it here. So we're going to multiply and divide by 2 plus I. The reason we have to do both, because this fraction is equal to 1. Otherwise, it's unacceptable. You can't just multiply by anything. It has to be 1. So when we multiply by this, what happens? As far as the denominator is concerned, we just follow that a squared plus b squared. So 2 squared plus, I hope you realize it's 1 squared. As far as the numerator is concerned, we're going to do the foiling. 3 times 2, 6, 3 times I, 4i times 2 is 8i, and this is 4i squared. And as I said, the bottom is 2 squared plus 1 squared. 4i squared, we're going to replace it with negative 4. Negative 4 and 6, they add up to 2. 3i and 8i, they add up to 11i, and this is 4 and 1, 5. So again, these two we add up. This is 4, this is 1, and we get 2 plus 11i over 5. You can leave it like that. However, if you cut it into two fractions, it becomes clear. A is 2 over 5, B is 11 over 5. So this is the standard form. If you left it like that, there's nothing wrong with that. As long as you can answer what is A, what is B. All right, anytime you want to multiply radicals where you have a negative number, you have to get rid of the negative. For example, in this case, we will follow this, and we're going to change this to 3i. This one is fine. Square root of negative 16, we change it to 4i. Again, we are using this. So this is 12. So you have 12i and 3i is 15i. I to the power of -6. There are different ways of approaching it. One way is to just flip it over because everybody remembers the negative exponential rule. I can take it down and make it positive. Remember 1 over, let's say, a to the power of -n is a to the power of n. A to the power of -n is 1 over a to the power of n. Now, how do we deal with powers of I? We look at this set. This set tells us, we know I squared is -1. We know I cubed is -I. We know I to the power of 4 is 1. We know that. What happens when it's larger than that? It goes back to one of those. So all you have to do, remember I to the power of 4 is 1. So if I have I to any power that is divisible by 4 becomes 1. For example, I to the power of 8 must be 1. Why is that? Because I can write it I to the power of 4 squared, which is 1 squared, which is 1. So when the exponent is larger than 1, there are different ways. Fastest way is to divide by 4. Doesn't matter what the answer is. I'm interested in the remainder. Keep the remainder. So this is 1 over I squared. You can even write it as I to the power of 4 times I squared, so I to the power of 4 is 1. So you just keep the remainder. And as you know, I squared is 1, so -1, so 1 over -1 makes it +1. Here's another example. If I want to do this, I'm going to divide the exponent by 4. And all I'm worried about is the remainder. It doesn't matter what the quotient is because that goes away, becomes 1. And if you divide it, the remainder is 1. By the way, how do you know that? You may remember from basic math that if you're dividing by 4, you look at the last two numbers, 25. If it's divisible by 4, it's divisible. But this one, 24 is, so the remainder is 1. So this is the same as I to the power of 1, which is I. I'm going to quickly give you another example. I to the power of 43. So what are we going to do? We are going to divide 43 by 4. Everybody knows 40 is divisible by 4. So what is the remainder? 3. Therefore, I to the power of 43 is the same as I cubed. And we know it to be -I. You really have to remember this. This is -I. We use it, we're done, everybody's happy. All right, we're going to move on. Square root property says if x squared is a, where a is a real number, x is plus minus square root of a. A very simple example, x squared is 49. X is not 7, x is plus minus 7. Reminding you of the square root property. Solving quadratic equation, ax squared plus bx plus c is by completing the square. A perfect square trinomial is a trinomial that can be expressed as a square of a binomial. X squared plus 10x plus 25 is x minus 5 quantity squared. So if you were to use completing this square, note that in every perfect square trinomial, the constant term, meaning in this case 25, is the square of 1/2 of the coefficient of the x term, or b over 2a. So if you look at this one, I hope you realize this is b. You divide it by 2, you get -5. You square it, you get 25. That's how you get this concept of a completing the square. And so if you have x squared plus bx equals c, you, by the way, if c is on the left, you move it to the right. And you add b over 2 quantity squared to both sides and solve by the square root principle. This is the synopsis of solving quadratics. And we also have the quadratic formula. The quadratic formula ultimately comes from completing the square. When ax squared plus bx plus c equal to 0, x is minus b plus minus a squared of b squared minus 4ac over 2a. That's a very important formula in algebra, and it gives us a lot of information. What's under the radical is called the discriminant. So if b squared minus 4ac is positive, we have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. If it happened to be a perfect square, it comes out. And what it means, if it's a perfect square, we could have done it by factoring. If it's 0, there's one solution. And if it's negative, there are two complex solutions. Those are complex conjugates. All right, let's go with completing this square. And by the way, it's a good practice to know it, but and when they ask you, you have to do it by that method. But in general, you can always use factoring if it's going to work out, or the quadratic formula. In this case, the very first step is to move the 7. So b is number 6. You're going to divide it by 2, becomes 3. You square it, becomes 9. So b is 6. Divided by 2 and square it. Now what do? You add that to both sides of this equation. So what happens to the left is that it will always be the variable, in this case is x, plus b over 2. Now, b over 2, including the sign. If b over 2 is 3, it's plus 3. If it's minus 3, then minus, whatever the sign. So it's always x, the variable. It may be a different variable. And b over 2. The right side, of course, you add up two numbers. This is x, this is 3. Now, take a root of both sides. And we're going to move number 3, and that's the final answer. Pretty straightforward. We want to solve this one. A couple of things we need to do. Here's the constant we are going to move. And here's a, we want it to be 1. We're going to divide by 2. So the very first thing is to move the constant. The next thing is to divide everything by 2. Now, so this is b, minus 7/2. You divide it by 2, becomes minus 7/4. I hope you realize that whenever you're dealing with a fraction, when you want to divide a fraction by a number, multiply the denominator by it. I want to divide by 2, so I'm going to multiply 2 by 4. 2 becomes 4, so minus 7/4. Square that, positive 49/60. So b, that's b, to divide this by 2, multiply the bottom by 2. You want to square that, minus goes away, this becomes 49, this becomes 16. So 49 over 16. And so we're going to add that to both sides. So what happens to the left side is what I just mentioned here. Whatever the variable, in this case c, and whatever b over 2. b over 2, so we're going to add b over 2. b over 2 happen to be minus, so minus 7/4 squared. The right side, we have to add these two numbers, and I hope you realize this one is like 32 over 16, right? Because we want to take a common denominator, so it becomes 81 over 16. So again, I want to make sure we understand what happened here. The variable, whatever it is, in this case is z, and b over 2, including the sign. Then add up two numbers. Now we're going to take a root of both sides. So this basically drops the square, and it becomes plus minus square root of 81 over 16. Now, as you know, this is 9 over 4. So this is 9 over 4. So we move the negative 7/4. If we add them up, 7 and 9, 16 over 4 becomes 4. If we subtract, 7 minus 9 is 2 over 4 is 1, negative 1/2. Negative 1/2. Okay. Very straightforward, everybody. All right. We are going to move on. So this one, we want to do it by the quadratic formula. So the quadratic formula is written on the right. Let me remind you of what we just did. And to use a quadratic formula, it has to be in standard form, meaning you got to move the 5 first. After you do that, a is 2, b is 4, c is negative 5, and basically you plug it into this quadratic formula. So minus b is 4, plus minus the square root of b, 4 squared, minus 4 times a is 2, c is negative 5 over 2 times a is 2. So I use different colors to make it absolutely clear as to what we are doing here. So this is 16. This is plus 4d. This is 4. So we get minus 4 plus minus the square root of 56. Now, before we continue, sometimes students make a mistake of crossing the 4 and say it's negative 1 plus minus the square root of 56. That's not the case, because you can't drop one term from the top. There are two terms, and if you want to drop 4, you have to find a common factor of 4. Now, square root of 56 is the product of 4 and 14. And as you know, 4 comes out as a 2. If I factor the 2 from the top, I get minus 2 plus minus the square root of 14 Now I can drop this 2 and change this 4 to 2, and here's my final answer. All right. What about this question? It is already in standard form. A is 7, B is 4, C is 3. Plug it in the formula. We, of course, have to memorize the formula as we did here. Let's simplify. (16) minus 4 times 7 times 3. 3 times 7 is 21, 4 times 21 is 84, so we have a negative sign, and this is 14. 16 minus 84 is minus 68. Now, number 68 is the product of 4 and 17. So what happens here is that 4 comes out as 2. Negative sign is changed to an I, and 17 remains. Now, before we move on, in many texts, sometimes even in MOM, my open math, they rather have this one in between, because sometimes one may be under the assumption that I is under the radical sign, which is not true. I is outside. So they may write this as 2. So this is minus 4 plus minus 2I square root of 17. As long as your positive I is out, I'm okay with that. By the way, you can see that there is a common factor of 2 we can take out. And these 2 cancels out. The 14 gives us 7, and this is the final answer, minus 2 plus minus the square root of 17, I over 7. Very straightforward. Solved by the quadratic formula. When you look at this question, it doesn't appear to be quadratic. If you multiply both sides by LCD, which is x squared, and of course you really have to add x can't be 0. The reason being is this says x can't be 0. The same thing happens here. So if you multiply by this, you get 2x squared. If you multiply that by this, you get 4x. If you multiply that by this, you get minus 1, and the right side is 0. Now, it has been transformed into a quadratic formula where a is 2, b is 4, c is negative 1. Again, it's a good practice to write this and plug it into the formula. So this is 16 minus and minus plus 8. So the radical, under radical, we have 24, needless to say. This is 4. Again, we notice number 24 is the product of 4 and 6. By the way, you want to simplify that. If there is a a perfect square number in there you want to take out. In this case, it's 4. And so you get this one. 4 comes out as 2. Again, we can factor out the 2. We have minus 2 plus minus the square root of 6. These 2 cancel each other. We get 2 in the denominator. And this is done. But again, I want to make sure everybody avoids that mistake of thinking we can drop this. You can cut this into 2 fractions. Let me write that for you. You could write this as minus 2 over 2 plus minus square root of 6 over 2. And this is negative 1. So perhaps you want to be very careful when you want to simplify in this manner, and therefore you won't make a mistake. All right. We want to solve this absolute value equality. Absolute value of 4x minus 7 equals 5. So here's the process. Before we go there, I want to remind you the concept of an absolute value. This is x. If x is larger than or equal to 0, and minus x if x is less than 0, and it's known as distance, the number of units, distance from 0. That's why every number, the absolute value is positive except 0, which is 0. And more importantly, I want you to understand the concept of this absolute value of x is x if x is larger than 0 or equal to 0 and minus x. This means really the opposite, because if it's a number, it's very easy to see. If I said, okay, what is the absolute value of 5? You know the answer is 5. But what is the absolute value of minus 5? You really are looking at this one, which says write the opposite of what's in there, which makes it positive 5. Why is this important? Because if you don't have a number, what's given is an expression, you should be able to distinguish between the two. So what is the process of solving an absolute value equality? First, isolate the absolute value so that the equation is in the form of absolute value of x plus b plus c. If c is less than 0, let's say it was minus 5 or minus 2 or minus any number, then we have no solutions. If c is larger than 0, then we move on. Separate this into 2 equations, ax plus b equals c, ax plus b is minus c, and solve both equations, and you always check. Since this is isolated, meaning there is nothing else left to it, we are going to move on and separate it into 2 equalities. We drop the absolute value, and we say 4x minus 5 is once is 5, once is minus 5. So I can do it in one shot and write down plus minus. That really means 2 equations. Move the negative 7, make it positive. Divide by 4. And so 7 plus 5, 12. Divided by 4 is 3. 7 minus 5, 2 divided by 4 is 1/2. So I hope you can see that. I can quickly show you this can give you 7 minus 5 over 4, which is 2 over 4, which is 1/2. 7 plus 5 over 4, which is 12 over 4, which is number 3. In the second case, part B, step 1 is the isolation. So we have to move this to the right. So we subtract it from 3. That is our first step. The next step is to make up two equations. So you either make up two equations or you use plus minus. It means the same thing. We move the negative 5, becomes positive 5. We divide everything by 2. And of course, we're going to combine it. So with a different color, I can say 5 minus 2 over 2 and 5 plus 2 over 2, 3 halves and 7 halves. Now, you really have to check your work. So what I'm going to do, I'm going to check one of them. In both cases, both questions, here you have to check both, put it into the original, and you have to check both, put it into the original. What I'm going to do, I'm going to check one of them and I leave it for you to check the rest of them. You always have to do that. So we are going to pick one. Let's say we're going to check this one. You always go to the original equation. So you're going to write 2 times x, which is 3 halves, minus 5 plus 1, and is this going to be 3? That's what we are going to work on. So we notice this 2 cancels out this 2. So we get absolute value of 3 minus 5 plus 1, absolute value of minus 2 plus 1. You get 2 plus 1 equals 3. Check marks, it's absolutely fine. So you got to check your work. It's really a good practice to do that. So this is how you solve equalities involving absolute value. How do we solve inequalities involving absolute value? Well, it depends whether it's less than or greater than. So since part A is less than, we're going to discuss that only for now. The absolute value of x is less than a, and if a is positive, x is sandwiched between negative and positive a. By any chance, if it's negative, there is no solution. I want you to know that. So first and foremost, isolate the absolute value. Whether it's equality or inequality makes no difference. The first step is isolation. It is completely isolated. There is nothing we have to do. So we move on from here to this step, which means we drop the absolute value. Since this number is positive 7, we keep it on this side and we take it also to the other side, make it negative. So please understand, you drop the absolute value, you keep this one, and then you say minus 7 on the other side. So you have a compound inequality, and you are going to solve for x by first subtracting 3 from all sides. So the middle term becomes 2x, left side becomes negative 10, right side becomes 4. The next step is to divide everything by 2. We get minus 5 less than x less than 2. Now what you have is the inequality solution. Inequality solution. Interval notation is this one. Minus 5, comma 2 is the interval notation. Notice we use parentheses because we don't have the equality. The endpoints, -5 and 2, are not included. We're going to graph it on a number line. So here's the number line. We want to go from -5 to 2. So from -5 to 2, -5 is not included, 2 is not included. You have two choices. You can put a hole here at -5 and 2, or you use parentheses. Either way is fine. So you can do it like that, or you can put a hole here and get another solid. And we are done with this. Now, what if it's larger than? If absolute value of x is larger than a, and a is a positive value, then x is less than minus a, or x is larger than a. That's how you go from an absolute value to two inequalities. Bear in mind, this is also two inequalities. Okay, -7 is less than 2x plus 3, and this is an and statement. Whereas this one is a or statement. That means intersection. What's in common in this case means union of events. And 2x plus 3 is less than 7. So what do? We do exactly the same as the previous inequality and the previous equality. We isolate. That means step 1, get rid of number 3. Step 2, divide both sides by 2. And since we just isolated this absolute value completely, we are going to go with this and say, since this is positive, x is less than minus a. So that means 3x minus 1 is less than or equal, because we have the equality -5, or 3x minus 1 is larger than or equal to 5. In other words, drop the absolute value and put the or in between, and then change this to less than, or in this case, equal. We're going to solve each one, which means I'm going to add 1 to both sides of each inequality. I'm going to divide both sides by number 3. And so x is less than or equal to -4/3, or larger than or equal to 2. Now, we are going to go over both the interval notation and graph it on a number line. So first and foremost, this is the solution. This is the solution. Here's the solution in interval format. -infinity to -4/3. That's the meaning of this part. X is less than or equal to -4/3. So -infinity to -4/3. Or that means union, 2 to infinity, 2 to infinity. Now, -infinity and infinity are concepts rather than specific numbers. Therefore, we will always use parentheses. Parentheses mean the endpoints are not included. See, the endpoints -5 and 2 were not included here. So that's -infinity and infinity. However, -4/3 as well as 2 are both included because we have the equality. So the endpoints 2 and -4/3 are included. Here's a number line. So we locate -4/3. That means -1 and 1/3. So somewhere here, we put a solid dot or a bracket, and we go to the left And this one, we locate number 2, bracket or a solid point, we go to the right, and that's what we get. This is minus 4/3, this is 2. So this is the graph inequality interval format. We want to solve this, and as you know, the first step is isolation. And we end up with this. When a is larger than 0, we cut it into 2 pieces, but because it's less than that, there is no solution. Why is that? Because absolute value in the worst case scenario can be 0, but not negative. So any number that is here, that is negative, results in no solutions. Results in no solutions, class. We are going to move on. We want to solve, and it's a good practice to check, square root of 2x plus 1 plus 7 equals x. Just like the absolute value equality, first we move the 7, we isolate, we're going to move the 7, we make this x minus 7. So we move the 7 because we want to isolate this. Now, since this is square root, we're going to raise it to the power of 2. If it was a cube root, we would raise it to the power of 3. So we would raise this to the power of 2. Therefore, we're going to raise the right side to the power of 2. The left side comes out. The right side becomes x squared minus 2 times x times 7, which is minus 14x plus 7 squared, or 49. So I'm going to remind you that if you have a plus b squared, you get a squared plus 2ab plus b squared. The right side is called the perfect square trinomial. If it's negative, you have a negative here. And that's what we have used. In order to solve this, we are going to take everything to one side. Since x squared has a positive coefficient 1 on the right, we're going to move everything to the right. So when we move that, we get minus 2x here, we get minus 1 here. These two combine to negative 16x, and these two combine into positive 48. Basic factoring. You can do it by the quadratic formula, but basic factoring, you want two numbers, the product is 48, the sum is negative 16. Those are 4 and 12. Because it's negative, both of them are negative. Therefore, it becomes x minus 4 times x minus 12. And so x is either 4. So you set this equal to 0. X is either 4 or 12. So we have two solutions. What do? We must check. When we raise to the power of even, things might happen. We may end up with solutions that will not work with the original equation, known as extraneous solutions, and that's what we must check. So let's check with 4. So let's plug in 4 into the original equation. So 2 times 4 plus 1 under the radical plus 7 is it equal to 4. So we're going to plug in 2 times 4 plus 1 under the radical. We are checking 4 plus 7 is that 4. And I hope you realize that this one is 8 and 1 is 9, comes out as 3 plus 7, and therefore 10 is not equal to 4. So that means x equals 4 is out, is not a solution, it's an extraneous solution. The terminology is extraneous solution, something that is extra, we didn't have it. And we don't have it in a manner that works with the original equation. So we're going to check the next one, number 12, which means we're going to put it in here. Square root of, and always the checking takes place with no step in between the very first given question. So 2 times 12 plus 1 under the radical plus 7 is equal to 12. That's what we're going to ask. And I hope you realize this is 24 with 1 becomes 25. Square root of 25 is 5. And 5 plus 7, yes, it's 12, and it does work. And there are 2 solutions, only one of them works. One of them is extraneous and is out. The only acceptable answer is x equal 12. We're going to move on. We want to solve this. Anytime you have a situation like this, you have to simplify, bring everything to the same side. So what do we do? This one, when you square it, becomes x squared plus 2 times x times 2, which is 4x plus 4. This one, you do the foiling, x squared minus 6x minus x plus 6, and I show you, so you should know this one is minus 6x, this one is minus x, so they add up to minus 7x. So I hope nobody has any problem with foiling or squaring things, and we can handle this easily. So when that happens, again, making sure we understand how to do both sides. Okay. Left side is a special product, right side is foiling. And we don't have to move this, they are identical. Then we can drop them without moving it. Now, we're going to move this one this way, and we make it plus 7x. We're going to move this one this way, and we're going to make it minus 4. This is 11x, this is 2, and divide by 11. And as always, you can check the work, and that's your final answer. All right, we want to solve this, and we notice it's been raised to the power of 5/3. By the way, the numerator is the exponent and the denominator is the index if you were to write it as a radical format. For now, we are going to undo this 5/3 by taking a root of both sides. So one way is to multiply that by its reciprocal, which is 3/5. If we multiply 5/3 by 3/5, we can get 1. So we're going to raise both sides to the power of 3/5. So this one to the power of 3/5, and this one. And so what happens is that the left side, when we raise it to the power of 5/3 and then 3/5, they undo each other. We get 4x to the power of 4x plus 1 to the power of 1, which we don't write because this ends up being 1. So 4x plus 1 to the power of 1 is just 4x plus 1. And the right side is 32 to the power of 3/5, which is the 5th root of 32 to the 3rd power. So reminding you that a to the power of m over n is the nth root of a to the power of m, or the nth root of a to the power of m. And that's exactly what we are using here. Why are we using this one? Because I hope everybody knows the answer is 2, because 2 to the power of 5 is 32. So this one is 2. And 2 cubed makes it 8. We're going to subtract the 1 and divide by 4. And that's the final answer. As always, you can go back and check your work. We want to solve this equation, and what we can do, we can raise this to the 2nd power, multiply it by 2, combine them and do the math. However, since this is 3x minus 4, this is 3x minus 4, we can do this by substitution. It's a lot faster and easier. So we let 3x minus 4 be anything except x, because we can't use the same variable to represent 3x minus 4. So if we let y represent that, this becomes 2y squared, this becomes plus y, and it's minus 1. All you have to do, factor this. It's a very simple factoring because 2 is a prime number. So it's 1 and 2. And negative 1 is just a product of 1 and negative 1. You have to figure out the order. And as far as the order is concerned, class, basically you put y and 2y here, and then you put 1 and negative 1 and play with it until the middle term works. What do I mean by the middle term? When you multiply these 2, you get 2y. When you multiply this 2, you get minus y. And these 2 must combine to give us y. Therefore, y is either negative 1 or 1/2. Now, if we were solving for y, we would be done, but that's not what we're solving for. We're solving for x. So we let 3x minus 4 be those 2, and we solve the 2 equations. So 3x minus 4 is either minus 1 or 1/2, and this is the one we are going to solve. So to solve this, we're going to move the 4, negative 4, and so 3x equals 3, and therefore this makes x equals 1. When we move this one, then 3x becomes, 4 is 8/2, becomes 9/2. If you divide by 3, becomes 3/2. And that's why these are the 2 answers. For part B, we also use substitution by letting x to the power of 1/3 be any variable except x. For example, m. When we do that, this becomes m squared, this becomes 2m, this becomes plus 3. Let me put at top of it. So this becomes m squared, this becomes 2m plus 3, and we're going to move everything to one side. So we're going to move everything to the left. Therefore, we can factor. We want 2 numbers. The product is negative 3. and the sum is -2, so -3 and +1. So m is either is 3 or -1. Again, we are not solving for m, we are solving for x. Therefore, we have to continue finishing the job. If x to the power of 1/3 is m, what is x? Raise it to the third power, and therefore x becomes m cubed. When that is the case, it's either 3 cubed, 27, or -1 cubed, which is -1. So this one would be 3 cubed. This one -1 cubed is -1. And you can always put it back into the original one. And that's really a good practice, to put it back into the original one and check it. To solve this, first and foremost, we move the -15. We make this r to the power of 4 minus 8r squared plus 15 equals 0. We have a choice. We can do it just the way it is, or we can do it by substitution, because it's not quadratic, but it is what's called in quadratic form. We can make it so by, if you let r squared be represented by, let's say, y. Let me do that, but you can factor it just the way it is. I'll show you quickly. If you let's say, y be r squared, then what you're looking at is y squared minus 8y plus 15, and you can factor it. Or you may factor it just the way it is. You want two numbers, the product is 15, the sum is -8, the answer is -3 as well as -5. So r squared is either 3 or 5, which means r is plus minus square root of 3, r is plus minus square root of 5 here. There are 4 answers. There are 4 answers here. What about this one? Well, again, you have really 2 methods. You can multiply both sides by b squared, or let b to the power of -1 be something other than b, for example, x. And if you do that, I hope you realize b to the power of -1 is x, then b to the power of -2 is x squared. So 6x squared minus 5x plus 1 equal to 0. We need to factor this, which is not too bad. Because 1 is just a product of 1 and 1, both of them positive or negative. 6 is either 1 times 6 or 2 times 3. And this will do the job because of the middle term. Again, this is minus 3x. This is minus 2x. They do add up to the middle term of minus 5x. And x is either 1/2, because 2x minus 1 is 0. That means x equals 1/2. And this means x equals 1/3. Now, I want to make sure we understand what this means. So this means 1 over b is x, and there 1 over b equals x. Or you can say b is 1 over x. Either way is fine. Or b equals 1 over x. So this is what we want, because then x is the reciprocal of a b. That's the meaning of 1 over b. So what is the reciprocal of 1/2? 2. What is the reciprocal of 1/3? 3. And those are the answers we are looking for, b. All right. Here's a simple word problem. Anybody wants to read this for us? Okay.
I'll read it.
Please.
A fitness club charges $20 as a monthly access fee and $2 per day of use. A. Express the monthly cost. C. In terms of daily usage. B. What will the monthly cost be if the club is used 15 days this month?
Perfect. So what we do, let's pick up a variable and let x be number of days. Then C, the cost, becomes a function of x. C of x is what? $2 per day, so 2x, and then the fixed cost of $20. So in essence, this $2, which is the variable cost, becomes the slope, and this fixed cost becomes the y-intercept, and we're going to call it the c-intercept because we are using c. In part A. For part B, how much are they going to cost us if we use 15 days? Replace the x with 15. $30 and 20, they add up to $50. So the month that we use it for 15 days, they charge us $50. Here's the last question. Could somebody read this one, please?
If the length of a rectangle is twice its width and its perimeter is 90 meters, what if the length of a rectangle is twice its width and its perimeter is 90 meters? Why is it written and? Sorry.
Thanks. We want to find the dimensions of the room.
Okay.
We want to find the dimensions of the room. And so we are dealing with a rectangular shape. One side is the width, one side, the larger side, is the length, and the length is twice its width, so it's 2w. So let's just make sure you understand this means this. And we know the formula, the perimeter is 2L plus 2W, or you might write 2 times L plus W. That's the formula, and it's 90 meters. So we know L is 2 times W, and we know P has this formula of 2L plus 2W, and it's equal to 90. So all we have to do, replace this L with 2W. So 2 times 2W. So if we replace this with 2W, then we get 4W plus 2W, giving us 6 of those. Divide both sides by 6, and it becomes 15. As always, pay attention to units when you're dealing with applications. If it's 15 meters, the length is twice that, makes it 30 meters. So for this question, the width ends up being 15, the length ends up being 30, and to check, all you have to do, add up 15 and 30, it's 45, multiply by 2, it must become 90, and that works out, and we just checked it. and that's it.